In one of my earlier videos, I had stated certain well-known properties of any triangle and the radius r of its inscribed circle. In this video, I shall prove those properties. With reference to the diagram, these properties are: the areas of a triangle is half r multiplied by within bracket a plus b plus c bracket ends, where r is the radius of the inscribed circle. This formula is applicable to any triangle. In addition, if the triangle is a right triangle, then the following properties also hold good. Property number 2, that is, r is equal to half a plus b minus c, where r, as before, is the radius of the inscribed circle. A, B and C are the three sides. This is A, this is B and this is C of the right triangle, where C is the hypotenuse. And property number 3 is, if CD, that is this, is normal to the hypotenuse AB, then M is also the midpoint of BC, that is this is the midpoint of this side, then dm is equal to cm is equal to bm is equal to half bc, that is dm is equal to bm is equal to cm is equal to half of this whole side, which is a by 2. And the fourth property is area of triangle CDM, that is this area, is equal to area of the triangle DMB, that is area of this triangle, and each of these areas is half of the areas of CDB. Each of these two smaller areas is half of the area of this triangle. We need to prove that the area of any triangle is half r multiplied by a plus b plus c, where r is the radius of the inscribed circle and a, b, c are the three sides of the circle. Now look at the diagram. Let O be the center of the inscribed circle. The circle is tangent to the three sides AB, BC and CA at points K, L and M respectively. Now draw lines OK, OL and OM. The length of each of these lines is R. Because AB is tangent to the circle at K, OK is normal to AB. Therefore, area of triangle OAB, that is this triangle, is equal to half base into height. This is height and this is base. That means half OK multiplied by AB, or half R into C. So this area is half R into C. Similarly, areas of OBC and OCA, that is these two triangles, first this triangle and this triangle, will be half R into A and half R into B. Sum of the areas of the three triangles then will be half R into C plus half R into A plus half R into B, and that is equal to, if you take half R common, then it becomes half R A plus B plus C. But the area of the triangle ABC is the same as the area of the sum of these three angles. First is this angle, second is this triangle, and third is this triangle. So, the area of the triangle ABC will be half R A plus B plus C. This is what we are required to prove. In the right triangle ABC, where angle C is 90 degree, the radius of the inscribed circle, that is this circle, R, is given by the formula R is equal to half A plus B minus C, where A, B and C are the sides opposite to the angle A, B and C respectively. Note that AB is opposite to the corner C, therefore it is the hypotenuse because angle at C is 90 degree. Now the proof is as follows. Side AC is tangent to the inscribed circle at G. This is tangent to the inscribed circle at point G. Hence, radius OG is perpendicular to the side AC. Similarly, this OF is also perpendicular to the side BC because this angle is also 90 degree. Therefore, angle CGO is equal to angle CFO is equal to 90 degree. This angle is 90 degree and this angle is 90 degree. It is given that this angle is 90 degree already. Therefore, this angle is also 90 degree. So, in this rectangle, all angles are 90 degree and this side is R, this side is R. So, all sides will be equal to R. To repeat, the quadrilateral CGOF with a square with all sides equal to R. CGOF is a square with all sides equal to R. Now AC is equal to B, that is this is equal to B, and GC is equal to R, this is R. Therefore, AG is equal to B minus R. AG is equal to B minus R. Similarly, this side is B and CF is R. Therefore, BF is equal to A minus R. Note that AG and AE are tangent to the circle from an external point A. So, from here, this is a tangent to the circle, this is also a tangent to the circle. Therefore, we know from geometrical theorems that this is equal to this. And because this is B minus R, this is also B minus R. Similarly, this is a triangle, this is a tangent to the circle, this is also a tangent to the circle, and B is an external point to the circle. Therefore, this length will be same as this length, and because this is A minus R, this will also be A minus R. Now, AE plus EB is equal to this side, which is nothing but C. Therefore, we get C is equal to A minus R plus B minus R, which is equal to A plus B minus 2R. Because C is equal to A plus B minus 2R, we get 2R is equal to A plus B minus C. Dividing both sides by 2, we get therefore R is equal to half multiplied by A plus B minus C. We were required to prove this property. Before going any further, please like, subscribe, share and hit the bell so that you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. More importantly for me, if you like, share and subscribe, it would encourage me to make and post new videos for you to follow. Also, if you know about any interesting problems that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. The third property we are required to prove is if CD is normal to AB, that is if CD is normal to AB and M is midpoint of BC and M is the midpoint of BC, then we have to prove that DM, that is this, is equal to CM, which is this, is equal to BM, which is this, and each of these three is equal to half of BC. Remember that we are considering this triangle ACB, which is a right angle triangle, and the right angle is at C. And the proof is like this. First, draw the perpendicular CD. Let the length of this perpendicular be H. Then extend DM to the point N such that the length of DM is same as the length of MN. Then join NB. Then consider the triangle CDM and triangle NMB. Now these two triangles are congruous because this side is equal to this side, that is we have drawn it equal, and it is given that this side is equal to this side, each of them being half of side BC, and the angle between the two lines, that is this angle, is equal to this angle. Therefore, angle CDM is congruous to angle NBM by SAS. Therefore, CD is equal to NB is equal to H. This is equal to NB, that is the third sides are also equal. This is the third side of the triangle, this is the third side of the triangle. So, these two are equal. Therefore, this being H, this also will be H. Also, Angle DCM is equal to angle NBM. Angle DCM, that is this angle, is equal to angle NBM, which is this angle. These two angles are equal because the two triangles are congruous. Let us call these two angles as alpha. In triangle CDB, that is in this triangle, DCB angle plus angle DBC is equal to 90 degree. That is this angle plus this angle is equal to 90 degree because this angle is 90 degree. Now this angle is alpha and this angle is alpha. Since alpha plus this angle is 90 degree, we get this angle plus this angle also 90 degree. Hence, this entire angle is 90 degree. Angle NBD is 90 degree. Angle NBD is 90 degree. Now in right triangle CDB, CB square is equal to, that is this square is equal to CD square plus DB square. That is H square plus DB square. Now, in the right triangle NBD, this square is equal to this square plus this square, or dn square is equal to h square plus db square. So dn square is equal to db square plus h square. Now since cb square is equal to db square plus h square and dn square is equal to db square plus h square, we get cb square is equal to dn square. That is cb square is equal to dn square, or this length BC is equal to the length of dn. And we know that dm is half of dn and dn is equal to BC. So dm is equal to half of BC also. So dm is equal to half of dn is equal to half of CB, which is same as Cm plus Mb, which are also half of BC. So it is proved that dm is equal to Cm is equal to Bm is equal to half of BC, which was required to be proved. Finally, we have to prove that area of triangle CDM is equal to area of triangle DMB, and both are equal to half area of triangle CDB. That is, area of CDM triangle is equal to area of the triangle DBM, and both these triangles areas are equal to area of the bigger triangle CDB. The proof is as follows. Draw a perpendicular from M on P. Draw a perpendicular from M on CD. Let the foot of the perpendicular be P. So this point is P. Now these two triangles CPM and CDB are similar. That's because all their angles are equal. This angle is common to both the triangles This is a right angle. This is also a right angle. Therefore, the remaining two angles, that is angle this and angle this, also are equal. Since the three angles are equal to each other in two triangles, these two triangles are similar. And when two triangles are similar, the sides are in proportion. For example, CM by CB, that is CM by CB is equal to PM by DB, that is PM by DB. This is the side of the smaller triangle, and this is the corresponding side of the bigger triangle. The ratio of these two is equal to another side of the smaller triangle divided by another side, corresponding side of the bigger triangle. So CM by CB is equal to PM by DB. But we know that length CM is equal to length MB, and both are equal to A by 2. Hence, CM by CB is equal to half. Because CM by CB is equal to half, we get PM by DB is equal to also half. PM by DB is equal to half, or PM is equal to half DB. That is, this is equal to half of this. Now, area of the triangle CDM, that is C, D and M, this triangle is equal to, like any triangle, half base into height. This is base, this is height, so it is half CD multiplied by PM, which is half CD multiplied by PM. But PM is equal to half dB. So, area of triangle CDM is equal to half CD multiplied by dB, which is this area. And area of the triangle CDB, that is this area, is equal to half base into height. This is base, this is height. So it is half of CD into dB. Half of CD into dB. Now area of triangle CDM is equal to 1/4 CD by dB. Area of triangle CDB is equal to half CD by dB. Therefore, area of CDM is equal to half the area of CDB. So this area is half of the area of the bigger triangle, this. Since area of CDB is equal to area of CDM plus area of DMB, that is, this area, whole area, is equal to this area plus this area. Since this is true, we have area of CDB is equal to half of area of triangle CDB plus area of triangle DMB. Hence, area of triangle DMB is equal to half area of triangle CDB. So, we have proved that area of CDM triangle is equal to area of triangle DMB is equal to half area of the triangle CDB, which is the final proof. Thank you.